decided to do my talk demystifying RxJS operators here from the sunny Aruba. So what I'm going to talk about is pretty much RxJS operators. And from my perspective, everyone is already to some extent familiar with the concept of operators and use it in a more or less daily work, depending on how often you use RxJS for sure. But barely anyone really knows about the internals of the operators and the underlying architecture of that. And when I don't have a clue about anything, the first thing that I'm going to do is check Wikipedia as a professional. And for operator, the Wikipedia definition is an operator is generally a mapping that acts on elements of a space to produce elements of another space. This is very mathematically, but it describes some of the concepts of RxJS operators fairly well. Just two more words about me before we dive deep into that. My name is Niklas Wortmann. I'm a consultant for Evora IT, and I'm a member of the RxJS core team since mid of 2018, and mainly responsible for the documentation there. One quick disclaimer before we really dive deep into the operators and everything. Some of the things that we are mentioned within this talks are heavy implementation details. So I want you to be aware of the concepts of RxJS operators. I don't necessarily want you to rely on some of the implementation details. Great. So I'm really bad at designing slides. So what I mostly did is just copying RxJS code into slides. So what is shown here is pretty much the underlying type definitions for operators. And within RxJS, we have basically three important types. We have the unary function, which is basically just a closure for a function taking a source argument and returning some kind of output value. This is completely observable agnostic, but already, if you remember what Dominic just mentioned, fairly similar shape. The operator function is using this unary function and now passing observable as type into that. So every operator function takes a source observable and returns another observable. Some of the operators that we have within RxJS are a little bit special, and we refer to them as monotype operator function because they have the same input as and output type. So if you think about filter, for example, the output type of filter of the source observable is not changed, and therefore it's a monotype operator function. This type definition is very technical. I want to take a step back now and take a look into operators more from a contextual point of view. So from my point of view, and as of right now, there's not really a definition out there what are the characteristics for an operator. From my point of view, there need to be two characteristics. And one, an operator needs to be composable, and it needs to add behavior to the source observable. So let's look at some examples. So map is a fairly known example of an operator, right? And it's actually a pretty good operator, as it adds behavior to the source observable by applying a projection function. And it's also composable because I can apply map several times in a row to an observable that works just fine. From my point of view, is not really an operator because it just creates an observable. It does not add behavior to an existing observable. Dominic in his talk mentioned multicasting, and also in Lemmy's talk, multicasting was a big topic. And within RxJS, at least as of right now, we have a multicast operator, and this is a little bit tricky. So we have several type signatures for multicast, and one of that returns a connectable observable. The problem with the connectable observable is that you need to call the connect method to make the underlying subject subscribe to the source observable. Therefore, it is not composable. On the other hand, if you use another signature where you can apply the selector function, then you get an observed value of, which is also an observable. And this way, it is composable, and you can apply other operators to it afterwards. These were now some examples. So from my point of view, responsibilities of an operator, it has to handle all the emissions, meaning next, error, and complete. And this can also mean that it just passed to the value. So for example, what Dominic showed is that he just called source observable complete, just to call all the other observables complete handler. Additionally, an observable needs to subscribe to its source observable and also take care of unsubscription. The last thing that is very important is that it returns a new observable. So these are the 6 big things that an operator needs to take care of that it is a fully functioning operator. With RxJS 5.5, we introduced the pipe architecture. And now that we handled all the basic concepts of operators on a high level, I want to talk about code again. So we remember the operator function looks like this. We take a function taking a source observable and returning another observable. If we think about that, this means that we can always apply the source observable to every operator. Therefore, code where we are used to write it like this, we're just using from, applying pipe, and some operators, we can also invert that and always pass the source observable manually. This is shown here on the right, and I promise you this is completely fine RxJS code. No one is able to read that and wrap his head around it, but it's completely fine RxJS code. So let's take a look in the pipe method itself. And again, lazy in designing slides, so I copied the code from RxJS, at least most of the code. And what it's doing is it's applying a big reduce statement over all the operators that are passed. And therefore, it's pretty much just calling the functions and passing the observable as source observable to the next operator. And therefore, it's inverting the function calls to make it more readable. There's actually a fantastic blog post by Ben about pipe methods in general. I can highly recommend you to check that out. So the big reason why we introduced this pipe architecture is actually tree shakeable. Before that, we had dot chaining, which was basically every time you imported an RxJS operator, it was patting the prototype of the observable, of the global observable. And this approach was not tree shakeable. By having functions that you now import dedicatedly, you end up with a way more tree shakeable approach. From my point of view, at least compared to the inverted function calls, it's also way more readable. And another nice benefit that we didn't mention so far is that it boosts extensibility in general. So it's way easier now to write custom operators than it used to be. We will take a look into this more in detail later. I want to circle back to this statement. Every operator returns a new observable. If this is true, code that we are used to write like this, where we are using a subject, for instance, to apply to switch map or take until, because it anyway returns a new observable, we can technically leave out this as observable part, right? And this is actually completely fine. The problem is introduced, or at least it seems in some cases, this does not apply. So if we take a look at the left example, our constant A returns an observable instant. In our problem B, even though we are applying an operator to a subject, we end up at compile time with an compilation error and at runtime with an anonymous subject. What the fuck? That's kind of weird, but I'm pretty sure we will figure it out as soon as we took a look into the lift architecture. The lift architecture was introduced with RxJS 5. It was the big thing of RxJS 5, and therefore way before my time on the RxJS core team. But the lift architecture consists of the 3 main steps that every operator has to take care of. It has to call source.lift. It has an operator class and an operator subscriber. So first of all, let's take a look at source.lift. What does this mean? To make this example way more comprehensible, I want to use the current implementation of map. So if we take a look into the map operator, we see that within the inner function here, we call source.lift and pass an instance of the map operator. Source.lift means there is an instance method called lift on the observable type. So let's take a look into this. What we have here is we are creating a new observable and we're returning that. And due to the fact that we're returning source lift, in the end, every operator returns a new observable. Seems about right. Additionally, we are calling observable, or we are specifying two metadata attributes, observable source and observable operator. This is actually where the lazy effect of operators come into play, because we're just passing the operator reference and call it later on in the subscribe. I want to take more look into this because the operator that we passed here is our map operator, our operator class. The operator class itself, all of those implements an interface operator. And this interface operator just defines one method called call, where we pass a subscriber and the source observable, and it has to return a teardown logic. Teardown logic is pretty much unsubscribe. So let's take a look into the map operator. We see it implements operator, so it has to implement the call method. And in the constructor of the map operator, we pretty much see the arguments of the map operator itself. So we got the projection function and the this argument, even though I've barely seen that in real world projects. But technically, you can specify this argument in the map operator as parameter. Let's take a look at call. So what we do here inside call is that we are returning source at subscribe. So we're subscribing to the source observable and returning that logic. And we're creating a new map subscriber and bypassing all the important arguments. Okay, let's take a look into map subscriber. And this is the biggest piece of code that I show. I hope it's still readable to some extent. What we do and this is actually the implementation of the map subscriber in RxJS as of right now. So we have our count variable and all the indexing stuff. But what is really important here is the next handle. So we just implement next, and this way, by extending subscriber, we ensure that error and complete are just passed through to the next operators. But all the logic take place in next. And what we do here is recalling the projection function and wrap that in a try catch just to ensure if an error is happening that we catch that error and emit it as over the error channel. If there's no error, we just call subscriber.next and therefore pass it to the next handler in our observable in our operator pipe. This is okay-ish. I quickly want to mention that this implementation is the map operator of RxJS master. There's right now an open pull request by Ben where the implementation changed a bit to make the library more smaller. I'm pretty sure he will talk about that later a little bit. If not, I can just recommend you to check out this pull request. It's super interesting to see what he did there. Back to the topic. Why is now calling operators on a subject returning an anonymous subject and not an observable? That's a big question here. The thing is, the observable implements a lift method, right? Where we create a new observable and return it. The thing is, subject also implements its own lift method where we create this anonymous subject. The anonymous subject is the underlying type of subject, so kind of the base type. I'm not even sure if it's publicly exposed. But this is where this comes from. And this behavior will change in the future for subject to some extent, but this is the current situation. Why did we introduce the lift architecture? It seems kind of complicated for what we're doing there. The main reason originally with RxJS 5 was that it was by introducing these functions, it was way more performant than having closures as it was before. On the other hand, and this is the reason why it keeps in RxJS, is the fact that it's introduced a nice customizable API. So what does that mean? What this lift architecture allows us to do is create own observable types just by extending observable and overriding the lift method. So what I did in this example, and I think it's also extracted from one of the tests of RxJS, is we created a lock observable that wraps every operator that is passed to it in a new lock operator. Within this lock operator, what we do here is pretty much taking care that everything that happens in all operators are logged. So if you take a look in the log subscribers, we're taking care of the next, error, and complete, passing them through, and logging what's happening there. If we use that in a small example, so we're creating a new log observable, calling some values on it, apply some operators, and we see a very, very detailed information, what happened, how the values change, and stuff like that. Please don't be confused that this lists do operator for tab here. This is due to the case that we never renamed the operator class for the underlying tab implementation. Never is probably not correct. I think there's an open PR which might already be merged for that. But anyway, this is why this keeps in place. The one thing that I wanted to mention here as well is that this lift method would also be the public access point for everyone who wants to write browser APIs, third-party APIs, debugging tools, stuff like that. This is the central hooking point into the RxJS library right now. Kind of an implementation detail, though. This was pretty much everything about operators in the current RxJS version. I can't do a talk about operators itself without talking about custom operators. And from my point of view, there are two big groups of custom operators. There are convenient or alias operators and greenfield operators. I want to start with the convenient or alias one, as I think those are the way more common. So I want to circle back a little bit, as we, as software developers, are used to the concept of creating constants just to give magic values name. The same goes actually with functions. We give it a name to make it more accessible, more comprehensible. For some reason, for functions and constants, this is quite common practice. This is barely used for anonymous functions where you have complex logic in a reduce statement, for example. Giving this inner function a name would already highly improve readability. And it actually gets way worse for RxJS code. And I can say that because the RxJS code written here is written by myself, and it's probably still running in production. So honestly, if I now take a look at this again, my reaction looks kind of like this because I need at least half an hour to just comprehend what all is happening. And I'm the one who wrote it, so it will be even more difficult for all my teammates. So what I recommend in these scenarios is just give things a proper name. And RxJS internally does the same thing. So start with, for example, it's just the convenient operators to wrap concat and apply a static value and then subscribe to the source observable. Concat map is just a convenient operator of merge map by passing a concurrency parameter with 1. Share is just a convenient operator of multicast and ref count, and it's actually using this weird inverted function signature thingy. I can not recommend you enough to do it on yourself. And I did a quick example here for a safe get method, which leverage switch map and also make sure to call catch error on the inner observable to ensure that errors are catched properly. This is just one example to make code more accessible, code more readable, and more reusable. The other thing is greenfield operators. And my first reaction when someone approaches me about greenfield operators is pretty much always like this. Okay, there are already over 100 operators in RxJS, and some of them are so barely used. So what the fuck are you actually doing there that you need another operator that is not already covered by the battle-proof tested RxJS operators? I guess sometimes there is a scenario that you want to do that. And for this case, I would recommend you to check out Ben and Tracy's talk of last year's ngConf. They covered the topic of building operators very much in detail. So this one is really great if you want to develop greenfield operators, even though I would not recommend you to do that. The slides are accessible with this QR code or this link. I hope this was helpful to some extent and gave you some insights about the RxJS operator implementation under the hood. I enjoyed very much being here, and thanks a lot for your time. And if you want to reach out to me, feel free to drop me a message on Twitter if you have any questions afterwards. I'm always around, and I also try to take a look into the chat of the conference itself. Additionally, very much thanks to the organizers for taking care of this conference in these very weird times, particularly for conference organizers. I really appreciate it, and I definitely appreciate doing this talk.